Alright, this video is to help you go over that quick assessment that we took last week. Okay, here are the answers to number 1 and 2. I would like for you to pause the video and discuss these answers with your group. And I want you to resume the video when you're ready to move on and everybody in your group understands numbers 1 and 2. Alright, for number 3 it says, which Riemann sum is greater? And you can see here I've circled trapezoidal because that is the answer. Let me just explain why. So for the trapezoid Riemann sum, what we would do is take the endpoints here, and really I could take any point, but I'm going to go ahead and go all the way to 2. But it really wouldn't even matter which one. And if I go ahead and draw a trapezoid, we can see that the trapezoidal sum is an overestimation. It's bigger than what the actual area under the curve, which, let me draw this in gray, the actual area under the curve would be all of this right here. If you can see this, that's the actual integral, okay? And so the trapezoidal is what we call an overestimation. All right, whereas the right Riemann sum would be taking a right endpoint, and so we connect this across, we can see that this right is an underestimation. Now definitely we could go into concavity and increasing and decreasing, and I want you to discuss that with your group. Go ahead and pause the video, and then when you're ready to move on, go ahead and move on. But I do want you to see that drawing a picture answers this question. All right, moving on to question number 4. We had to evaluate this integral. What I was really testing here is, do you understand that the area under the curve is the integral? And I told you to stop at 6. It's kind of hard to read on here, but to go from 0 to 6. So you weren't supposed to go any further than that. Now, in order to do this, you had to find the area under the curve. All right, and so looking at this area right here, that's a trapezoid. So now I can average the two bases. So that would be, the bottom here is 5. The top there is 2. So I would average that. And then I would multiply that by the height, which is 2. And these 2's end up canceling out. So this area right here ends up being 7. Okay, now if we look at the area down at the bottom, I'm going to go ahead and switch colors. All right, because this area is underneath the curve, which means that we're going to subtract. And so since that's a triangle, that would be 1/2 times the base times the height, which ends up being 1. But because this area is below, we're going to subtract the 1, and therefore 7 minus 1 ends up being 6. The answer here, 6. Okay, if you have any questions, I want you to pause the video, discuss it as a group, and then resume the video when you're ready to move on. Okay, on number 5, we're estimating the integral from 1 to 6, which I can see is how far this table goes, using a trapezoid approximation, 5 equal subdivisions. So basically I should have 5 trapezoids that I add up, okay? So I'm really going to challenge you here, and I'm going to do a little bit of graphing, but not a whole lot. So let's look at our first trapezoid here, because if I'm going to do 5, I pretty much have to do all of them. I can't really be skipping any values here. And so if I were to graph this trapezoid, which I'm not going to do this for all of them, but I want you to see, if I were to graph this trapezoid from, if my x values go from 1 to 2, that x distance, this width right here would be 1, and then the y values go from 5 to 7. Okay, now if I turn this trapezoid on its side, it makes a little bit more sense of how I'm going to add this up. I'm going to average the two bases, 5 plus 7, and then I'm going to multiply by the height of the triangle, which really looks like the width. Okay, and so times 1. All right, and what I'm going to do, let me switch colors here just to show this. Really, I averaged these two numbers, and then I multiplied it by the difference of those two numbers. This is a way you can think of it if you think that might help you. All right, so then there's always going to be some overlapping here with these trapezoids because they're right next to each other. The next trapezoid is really connected to that first trapezoid. They share a side, okay? And so I'm going to start with 7, and you can kind of see the pattern here. Now, I'm explaining this, and I want you to talk about it with your group, but I also want you to know that there are some good videos on Riemann sums on my YouTube site, so you may want to go back and watch the full videos. All right, so now I have 2 trapezoids. Remember, I need 5. All right, so overlapping again, remember, so then I got 11 plus 15 over 2 times 1, and then some overlapping again, plus 15 plus 21 over 2 times 1, then I got one more because I need 5. 21 plus 29 over 2 times 1. Okay, and I want you to go ahead and pause the video and do the calculation, and you could probably do this without a calculator, but if you needed a calculator, you would have it on the test. Okay, so pause the video, find the answer, and then play it to see if your answer's correct. Okay, hopefully you did the problem by now, and the answer you should have gotten is 71. Okay, when you're ready, go ahead and move on to the last problem. Okay, on this last problem, I give you the table, I give you the work, and I ask you what type of Riemann sum. Like in the last problem, it was trapezoidal. On this one, it may be trapezoidal, maybe something else. And I ask you how many subintervals of equal width. Okay, now the second part is actually the easier thing. I see 4 things, okay? I see 130 times 2. I'm just going to rewrite this down here because I want to write it bigger. 118 times 2, 108 times 2, and 120 times 2. And if you notice each time, it's times 2. Okay, first there's 2 things we want to see here. I see times 2 each time, and how many units do you see? You see 4 units. That's our answer right here, 4. 4 subintervals of equal width, the equal width being 2. Okay, so I'm going to go ahead and mark this down. There's my first one. My second one then would be 2 to 4, then 4 to 6, then 6 to 8. Okay, so we got that. All right, the next thing I need to look at is the numbers, 130, 118, 108, and 120. Now if I circle these numbers in the table, then I can see that, like, let me just really darken in this first one. So here's the first unit. Would you say 130 is the left, the mid point, the right, or is it, am I averaging? You know, here's the deal, I'm not averaging. How do I know I'm not averaging? There's no divide by 2, which is what you got to do with the averaging. So this is definitely not trapezoidal. So it has to be left, right, or midpoint. 130 is obviously not the left. That would be 120. 116 would be the right. 130 is the midpoint. Let's just kind of look to make sure the other ones follow suit. So let me change color pen here just to be like really clear. Okay, so then my next interval, remember, was from 2 to 4. And 118 was the number for that midpoint, right? Let me change colors again. And you can see it continues. So discuss this with your group and make sure you understand why this is a midpoint and not a trapezoidal left or right, and why there must be 4 subintervals of equal width. Okay, now that you have had your mini review, I want you to go ahead and start on your review, and I want you to refer to the paper to see which numbers you're going to do. Okay, don't just start with number 1 and go to 2, 3. I want you to do the review numbers that I have written on your paper. So you need to look on the paper. Ask me Ms. Brooks if you have any questions. Thank you.